So hello everyone. Today we'll talk about the stable matching problem and the solution that we can get for this kind of problem. So let's get started. Today we'll talk about the stable matching problem. So let's say that we have some n number of men and n number of women, and our goal is to match men and women. So we have 5 men on the left side, as you can see, and 5 women on the right side. Um, each of the men has some like letters to identify um, that person, and for the woman we have digits from the 1 to the up till the 5, and our goal is to match 5 boys with the 5 girls. So let's try next approach, and so each of the boy has its own preference list, like the most preferable girl for boy A is girl number 3, then second most preferable is girl number 2, then third most preferable is girl number 5, etc. till the end of the list. And it applies for all other boys. For girls, girls also have their own preference list, and for example, for girl number 1, the most preferable boy is boy number C, then the second most preferable is boy number E, then third most preferable is boy number B, and etc. And same applies for all other girls. So in order to match these 5 boys and these 5 girls, we need to first try first come or first serve approach, or also called greedy approach. So um, of course, traditionally, boys do the first step, and we start from the first boy, which is a boy A, and the most preferable girl for boy A is girl number 3, and boy A goes to the girl 3 and makes offer. At that time, girl number 3, she doesn't have any other offers, so she accepts the offer, and after that they get married. Then we remove the girl 3 from all other preference list of other boys because she already got engaged. So we move on to the next boy. We move boy B, and the most preferable girl for him is girl number 1. So he goes to the girl number 1 and makes offer. And at that time, girl number 1, she doesn't have any other offers, so she accepts that offer, and they get married. And of course, we need to remove girl 1 from other preference lists and move on to the next boy. Next boy is boy C. So for the boy C, the most preferable girl is girl number 4. So he goes girl number 4 and makes offer. Of course, girl number 4, she doesn't have any other offers at that time, and she accepts that that offer. And of course, we need to remove girl number 4 from other boys list. Then next boy, for the next boy, the most preferable girl is 2. He makes offer and they get married. Next is boy E and girl 5. So at that time there are no more other girls, and boy E makes offer and girl 5, she accepts the offer, and they get married. But after this approach, we can have the next situation. So boy A get married with girl 3, and boy D got married with girl 2. But for if you take a look on a preference list of the girl 3, we see that boy D is more preferable than boy A. So boy D is on the first place for the girl 3, then her current partner, who is the boy A. Boy A is located on the first place. And same for the boy D. Right now, the current partner of boy D is girl number 2. But if we take a look at the preference list of the boy D, we see that girl 3 is more preferable than girl 2. So girl 3 is more preferable than girl 2. So we will have this kind of instability when from the both sides, when we have situation when one boy prefer other girl more than his current partner, and same for the girl 3, she prefer other boy than her current partner, and we can have this kind of situation. So pair D and 3 is called a rock couple because it leads to the unstable marriage. So instability happens if element A prefer element B more than current partner of the element A, and same, and vice versa. Boy A, the element B, prefer element A more than the current partner of the element B. But in order to solve this problem, the matching should be stable, and the stability, the definition of the stability is next one. It should satisfy two conditions. The first one is matching is perfect, so it means that everyone has a pair, no one is a single. And the second condition is that there is no unstable matching. There is no situation like this. So in order to solve the problem, we need to discover the next algorithm, which is called Gale and Shapley. In 1962, David Gale and Lloyd Shapley, they invented an algorithm which can find the stable matching for the equal number of men and equal number of women. So, but one of the very interesting situation happened in 1984. Alvin Roberts from the Harvard, he figured out that actually this algorithm is already used before David Gale and Lloyd Shapley invented it. And that algorithm was used in a program called National Resident Matching Program, where medical universities needed to organize internship of the students in hospitals based on the preference list of the students and the hospitals. So this algorithm was used to help to find the internships for the medical students, as well as for the hospitals to find the most preferable students. So the main idea of the Gale-Shapley algorithm is that women, even after getting engaged, women still can consider another offers. And if someone with a higher ranking offers, she can drop her current partner and get engaged with a new partner. And the time complexity of this algorithm is big O of n squared, means that n is the number of men or woman. So in this algorithm, at each step, man offer the woman that he prefers most. So again, let's go back to the initial situation when we have 5 boys, 5 single boys, and 5 single girls, and each boy is denoted with alphabetic letter, as well as the girls has some unique ID number. So again, the goal is the same. We need to match 5 boys with 5 girls. So, and of course, each boy has its own preference list, as well as the um, girls have its own preference list. So again, we start with the boys, and boy A do the first step, and of course he goes to the girl who's most preferable to him, which is girl number 3. And boy A offers the girl C, but she doesn't say yes. She says maybe. So they kind of engaged, or also called provisional couple. Then we have boy B, and boy B, the most preferable girl is girl number 1. So he goes to the girl number 1 and makes offer, and girl 1, she doesn't say yes, she says maybe. So again, they kind of engage, and they all also call provisional couple. Then we have boy C. For the boy C, the most preferable girl is girl number 4, so he goes girl to the number 4 and makes offer. She says maybe. Then we have the boy D, and the most preferable girl for the boy D is girl number 1. And this is when we have the interesting situation. So he goes to the girl number 1. If you remember, girl 1, she already kind of engaged with the boy B. So what does the girl 1 do? She take a look at her preference list, and she sees that boy D is not more preferable than boy B, because as you can see, boy B on the 3rd place, meanwhile boy D is on the 5th place. So she refuses the offer, and so we remove the girl number 1 from the preference list of boy D, and the next girl on his list is girl number 3. So he goes girl to number 3, and if you remember, girl 3 is kind of already engaged with boy uh, boy A. So girl 3 take a look at her preference list, and she sees that boy D is more preferable than her current partner, who is boy A. So she um, kind of refuses. So she kind of drop boy A and accept the offer from the boy D. So after this situation, boy A is single again, so we remove girl 3 from his preference list, and we on the next person on the preference list of boy A is boy girl 2. So he goes to the girl 2 and makes offer. At that time, girl 2 is single, so she doesn't have any offers, so she says she accepts the offer from the boy A. So they kind of become provisional um, couple. And the next boy, who is still single, is boy E. So boy E, the most preferable girl is girl number 1. But if you remember, girl number 1, she's still with boy B, so she take a look at that offer and take a look on her preference list, and we can see that boy is more preferable than her current partner, which is a boy B. So she drops boy B and accepts the offer from the boy E. So boy E and girl 1, so they become kind of engaged, but boy B becomes single. So he becomes single, so we remove girl 1 from his preference list, and we go to the next girl, which is girl number 2. So he goes to the girl number 2, and if you remember, girl 2, she already engaged with the boy A, so she take a look at her preference list and she sees that the boy B is more preferable than boy A, so she drops boy A and get engaged with the boy B. So after this situation, boy B is again single. So we take a look at the preference list of the boy A. So girl number she already dropped him. Same for the girl 2. So he goes to the girl number 5 and makes offer. But as you can see, girl 5, she doesn't have any other offers at that moment, so she accepts the offer from the boy A. So in the end, we matched every boy with every girl, and no one is single. And so boy A is matched with girl 5, boy B is matched with girl 2, girl 3, she matched with boy C is matched with girl 4, boy D matched with girl 3, and boy E is matched with girl 1. So if we summarize this algorithm, we see that from the woman's perspective, of course, she starts single, but once she gets engaged, she can only improve her situation. She can only, at each step, she can only engage with a much better preference, with a much better boy. From the man's perspective, of course, he also starts single, but after each step, there is a possibility that he can be dropped by his current partner and get worse or get settled with a woman with a lower ranking. As I said before, the time complexity is big of n square, so also algorithm terminates after n square iterations. Solution is perfect matching, which means that everyone has a pair, no one is a single, and solution is stable. There is no like a rock couple. But in order to prove that this algorithm is correct, we need to consider the next situation. Let's say that we have this kind of pairs. So this man is engaged with this woman, and this man is engaged with this woman. And let's say that M prefer this woman more than his current partner, which is this woman. But we need to question, did M propose to this woman at some point in the execution of the algorithm? If no, then this woman must be in a higher ranking than this girl. If yes, he must be rejected in the favor of this man. So again, it's a contradiction, which means that this algorithm is correct. Of course, Gale-Shapley algorithm can be used not only in the matching man and woman. This algorithm can be used in many different places where we need to match two sides according to their preference list. And one of the examples where there is necessary to match the intern students in the medical universities. As you know, in the medical university, they need to have something like internship in the hospitals. And another example where you need to fix the problem of matching students with the courses. So each student has its own preference list of the courses, and the Gale-Shapley algorithm can be used in order to solve this kind of problem. So that's it for today. Thank you for watching the lecture, and wish you to be in the higher rankings of any other preference list. So that's it. Thank you very much. Bye.